Hello, learner. Welcome once again to Manifested Online Classes. My name is James Kenyani. We are going to proceed with our topic on similarity and enlargement. In our today's lesson, we'll tackle an area which talks of linear, area, and volume scale factors. But in the lesson today, we shall dwell mainly on the linear scale factor. So in the lesson we'll dwell on linear, area, and volume scale factors. So in this lesson we are going to deal with linear. So the objective is to enable the learner to interpret linear scale and use it to work out questions involving linear scale. Before we proceed, one could ask himself, where is linear scale going to help me? Later, in your stages of learning, for those who will interpret maps, we shall have the architects, we have the surveyors. You need a good interpretation of scale, and the basic moments of that starts with linear scale. Linear scale. It starts with linear scale. So, what we note here first, so we look at that, where you find objects are said to be similar if their corresponding angles are equal and the ratios of their corresponding sides, the ratios of their corresponding sides are equal. The ratios of their corresponding sides are equal. We are going to look at two triangles. So let's take a look at those two triangles, ABCD and PQRS. One would say these two triangles are similar. They are similar because they are similar because their corresponding angles are equal. Their corresponding angles are equal. If you look at this angle, DCB it corresponds to SRQ. If you look at angle CDA, it corresponds to RSP, and it is a right angle. Let's look at the ratios of their corresponding sides. If we look at, this is 3/2, it is equal to 6/4. 6/4. So you can say so when we say the corresponding angles are equal, we can give an example. Angle CDA angle CDA is equals to Q is equals to RSP. And DAB, angle DAB is equals to SPQ. Then we also note the ratios of their corresponding sides So the ratio of their corresponding sides is equal as we've seen. So these two happens to be the linear scale. If we are relating triangle A, if I call this the first triangle, if you relate triangle PQRS and triangle ABCD, this happens to be the linear scale. This ratio so sorry, it's not a triangle as mentioned, it is a rectangle. So this ratio of 2 is the linear scale factor when comparing rectangle PQRS and ABCD. ABCD. So if you compare the sides, like DC corresponds to SR, meaning SR is equals to 2 DC, where 2 is the linear scale factor. So that 2 is the linear scale factor. Let's look at an example. So the question can arise: triangle, not triangle, rectangle, not triangle but rectangle, ABCD is similar to rectangle PQRS. Find the size of PQ. So the question arises there. These two triangles are actually similar. So they're asking you find the size of PQ using the linear scale factor, which happens to be the ratio of their corresponding sides. So we'll move to the solution. So the solution. In the solution, we know length, linear scale factor will be equal to length of the bigger, or it'll depend on what you've been given, what is unknown. So you can use even the width. So in this case, the width of the larger triangle divided by the width of the smaller rectangle. So sorry, I've been mentioning triangle, but it is rectangle. So the width of the larger triangle is 4 divided by 2. So we get what? The linear scale factor. The linear scale factor is equals to 2. The linear scale factor there is equals to 2. So if you want to get the length of the bigger one, here length of PQ will be equal to length size of PQ is equal to linear scale factor times its corresponding side, AB, times AB. So the linear scale factor there is 2 multiplied by 8 centimeters, and it will give you 16 centimeters. Alternatively, one would go to the ratios, ratios of corresponding sides. You can say RQ using ratios of corresponding sides. One would simply say RQ divided by BC should be able to give you PQ over AB. So you'll substitute RQ is 4 centimeters, BC is 2 centimeters. That should be able to give you PQ, which is unknown. PQ is unknown, and AB is 8 centimeters. So learner, by cross multiplication, PQ will be equal to 4 centimeters times 8 centimeters divided by 2 centimeters. So this centimeter will cancel with that. 2 there, 1, 2 there, 2. So PQ gives you 16 centimeters. So as you understand a linear scale factor there, you are able also just to use the ratios to get the value of PQ. So just as a recap, when we have two similar triangles, a linear scale factor exists there to transform to get the size of the second one. You have to multiply by a certain constant number, which we call the linear scale factor, to get the corresponding length of the bigger rectangle. So then, as we've seen there, the angles should, corresponding angles should be equal in such similar triangles. So for the assignment, so you are given questions there. Find the linear scale factor if the two triangles are similar. Find the linear scale factor if the two triangles are similar, and also find PQ. So work out that question before we meet in the next lesson to proceed with another lesson on the same. So thank you very much for the audience. Have a nice time, and let's meet in the next lesson. Bye-bye.